we're gonna talk about the difference between compound and simple interest. So this sentence is incomplete. There should be a word here, either simple or compound. So we placed $5,000 into a bank account with an annual, simple or compound, interest rate of 6%. How much money is in the account after 1 year, after 10 years, after 30 years? So simple interest is mathematically simple, but it's a little bit more complicated to imagine. Money that collects interest is usually called principal. So in case of simple interest, you need to imagine that the principal and the interest are separated, never to meet. You need to imagine that the interest is getting deposited into another account. So, but that means that it's mathematically simple, because simple interest is characterized by the principal is not growing and the interest payments are always the same. For the first year with a simple interest rate, we're gonna have to compute 6% of 5,000, which is $300. The money in the bank after 1 year is 5,000 plus 300. After 2 years is 5,000 plus 2 times 300. After 3 years it's 5,000 plus 3 times $300. After 10 years it's 5,000 plus 10 times 300. So let's see, these values are 5,300, this one is 5,600, 5,900. After 10 years, the interest is 3,000, so we have $8,000 in the account. And finally, 9,000 plus 5,000 is 14,000. Okay, so that's with a simple interest rate. By the way, the word annual is from annum, which is a Latin word meaning year. So if they say a monthly interest rate, then the number of months, every month you get interest payments. But the yearly is expressed with annual. Okay, now compound interest is simpler to imagine, but mathematically more complicated. After the first year, there is no difference between simple and compound, so we get the same 5,000 plus 300. But now the $300 gets deposited into the account, and the next increase of 6% is now 6% of this larger amount. So we would have to take 6% of 5,300 and add it to 5,300, and we need to find that so that we could take the 6% of that and add it to that to get the next year's interest payments. So we seem to be in trouble mathematically, because it looks like there is going to be a lot of work to work ourselves up to 30 years. Except there is a shortcut. Remember, we talked about that increasing 5,000 by 6% can be done by finding 6% of 5,000 and adding it to 5,000, as we just did. But there is a shortcut to it. We can cut to the chase and say, why don't we just compute right away 106% of 5,000? That would be 6% added to 5,000. 1.06 is 106% as a decimal, and we should get the same result, and we do. Now, why is this helpful? This is very helpful indeed, because instead of this, we can just say it's 1.06 times 5,000. And then for the next year, how would we compute the amount money in the bank? We would take 106% of that. That would be 1.06 times 1.06 times 5,000. And for the next year, we would just take 106% of the previous. I think you know where this is going. Using this shortcut, after 2 years, this would be 1.06 to the second power times 5,000. With simple interest, it was 5,600. With compound interest, is $5,618. So what is that $18? That is basically the 6% of the previous interest. It's the 6% of the 6%. The difference being that in case of compound interest rate, interest becomes principal and the next year collects interest. Now this here would be 1.06 to the third power times 5,000. Now numbers will stop being nice. When that happens, we should round correctly to the nearest penny. This button here is your exponent button. It's like an upper arrow. So instead of 5,900, now we have $5,955.08. Now let's see after 10 years. So under simple interest, we just kept getting the same $300 as interest, so 10 times that was $3,000. In case of compound interest, and now this is the moment where that shortcut, this shortcut that we discussed, becomes sort of mandatory. It would take quite a lot of time to work ourselves up to 10 years and then 30 years without that trick. But with this shortcut, it's simply 1.06 to the 10th power times 5,000. Because each year we would multiply the previous year's amount by 1.06. And so 1.06 to the 10th power times 5,000. So we have $8,954.24. So the difference is almost $1,000, right? So it kind of adds up. And after 30 years, we would have 1.06 to the 30th power times 5,000. And so now, with a compound interest, it's more than twice the amount that we would get with simple interest. Right? With simple interest, we get $14,000 in the bank after 30 years. And with compound interest, we have $28,717.46. Now that's a difference you can feel, right? Twice as much. Thank you for watching.